Here's some video guidance for exercise 2 on page 185. So again, it's always assumed that you tried this first and then you're coming to the problem for some guidance. Remember, try it on your own. That's part of what the preparation for the final is there for. So you got two events, L and C. And one is you left your notes in the library. C is you left them in the classroom where inductive logic is taught. And then it's asked to assign some probabilities to this. So these are your events. The probability of L will equal what? Probability of C will equal what? So L, let's say you left your notes in the library. You were just studying there. Let's say it's 80%, just for the heck of it, right? We don't know. Or better yet, 90%. Let's make it 90%. Why? Because you were just there. You haven't seen class for a while. The second one is you left the classroom where your course was. So this says 10%. They always have to even out. Your priors, these are right here are your prior probabilities. They always have to add up to 100%. So when you diagram it, when you step this through, don't just stick in any old numbers. You have to think it through. So what is your full space, your partition space? Well, one, you left it in the library. Two, you left it in class. There's only those two options. This 90%, that 10%. They have to add up to 100. If you didn't get this adding up to 100, that means you probably didn't do the diagram. Certainly you didn't do the diagram correctly. Okay. Next, they ask for some likelihoods. So E says a friend saw someone's notes lie in the library, but she has no reason to think they're yours. They just saw someone's notes. She doesn't know who, right? So in this case, the probability of one likelihood would be E given that you left them in the library, and the other one is the probability of E given that you left them in the classroom. So given that you left them in the library, the chances that your friend, what she says is accurate, that it might be your notes, you think, oh, that must be higher because your friend added some evidence to this. They saw notes that look maybe like they're related to logic and they could be yours. So let's say that's 80%. And then this one, given that you left them in the classroom, if your friend told you that I saw some notes in the library, you would think, oh, that has nothing to do with what I'm doing. So let's say 1%, because given you left them in the classroom, your friend's testimony about seeing notes in the library with logic have nothing to do with you, right? But it could be yours. I don't know, but that's just low probability. Remember, these don't have to add up to 100%. These are the likelihoods. They can add up to whatever. Okay, and when you diagram it, this is E and E. One is basically saying, given L, what is E? So given L, what is E? 80%. Given C, what is L? 1%. The diagram here reflects what information you're given. That's why the diagrams are so important. Okay, now you're doing beige. You're doing the posterior. Posterior is basically what you calculate afterwards, right? And by now you guys should be able to do this. We did this for the first half of the course, so this is nothing new. So the probability of, you asked for two things. Probability of L given E and the probability of C given E. I'm only going to do one of them because you can do the other one on your own just for practice. You should all know how to do this by now. So that's, always do the Bayes formula first. If you guys start sticking at numbers, this will screw you up, and I cannot give you proper credit on the test. If you make mistakes with the calculation, but you show me all your work and you do the right type of work, I can give you more credit. So always show me the formula. So it's the first probability of L times the flip probability of E given L divided by the same plus not the first, which is, in this case, not L is C. So probability of C times the probability of E given C, right? Okay, and you stick those numbers in. That'll be, just read it off the diagram. So 80% times, 90%, that's the probability of L times 80% divided by the same thing plus 10%, that's C, times 1%. You guys can do the calculation on your own, but if you need some guidance, here's an easy way to do it. You just drop the percentage. So it'll be 90 times 80, 90 times 80, plus 10 times 1, right? And you do that calculation, 9 times 8 is 72, 20, so 7,200. 7,200 plus 10 times 1 is 10. So 7,200 is plus 10 is 7,300. 7,200 or 7,300, you drop the zeros, that's 72 over 73. That gives you the exact answer. But you can think that's so close to one another that that's pretty much 99%. That's how you do these things rough-handed. I mean, that's how basically you can calculate without having to do an exact calculation. Yeah, you guys should be able to do this right now. There's a prereq for math that you guys meet for this course, all of you should be able to do basic calculation. Okay. Now for the next part, the more interesting part, you're given some new evidence, and then you have to formulate likelihoods. So this is your posterior. What I got right here is 99%, okay? That right there. Now you're told that F, another friend, says he saw something or other with your name on it. It doesn't mean your notes, just something or other with your name on it in the library. So now you got to calculate new posteriors. New likelihoods. So that'll be probability of what? Not F given this or given F. It'll be F given L and E. Okay? And then the other one would be probability of F given C and E. Okay? So we got to assign some numbers to these things. So what I'm going to do here is I'm just going to make them up. The probability of F given L and C, well, let's think what this says. Given that you left your notes in the library, and given that another friend says they saw some lecture notes, what are the chances now that the other friend saw something or other with your name on it? What are the chances that that's really yours? You think, oh, that's really likely now. That's 99% chance that that's my notes I left in the library. And the other one says, given that you left it in the classroom and someone saw, well, if you left it in the classroom, all this other evidence doesn't matter. So that's still, let's say, 1%, okay? Remember, these don't have to add to 100%. It just happens right here that I made it into 100%, but it doesn't have to be that way. This could have been 0.01%, something really small, 0.1%, whatever, right? Okay, now the key part. So when you extend this to Bayes, when you're learning from experience, you're extending this out now to have F, right? So this one right here, this will now be, when you got the L and E, the F now is going to be 99%. It went up from 80 to 99%. And this one is still, it should actually maybe be even lower, but let's just say 1% to keep it, we're trying to keep the numbers easy, right? So when I go back to this problem, how do I calculate Bayes? It'll be, this is the new posterior. I'll just say new post. It'll be, I'm only going to calculate the first one just to give you a feel for this. So probability of what? You guys remember? So it's given something. What are you given? This new F, right? What goes on this side? F given what? Well, L and E. What are the chances, given this new information from your friend F, that the library, the book is in the library, and you got this other stuff? That equals, it's basically the same formula. The first, it's actually, sorry, I made a mistake here. It's not L and E, it's L given E and F, yeah? So L given E and F. Given these two pieces of information, that's your evidence. Evidence 1, evidence 2. How does that update the likelihood, or the chance, I shouldn't say likelihood, the chances that your notes are in the library? That's what L represents, library, not likelihood. Okay, so that's, remember, the first probability of, and now this is the first right here, L given E. Probability of L given E times the flip, this is the remaining part, so probability of F given L, and E, divided by the same plus the opposite of that. So probability of, what's the opposite of L given E? C given E. And the probability of F given C and E. Okay, how does that work? What's the first here? Well, the first is, remember, you're updating, you're learning from experience. So the first is now the thing you just calculated right here, the 99%. This first right here, L given E, yeah, that's corresponding to your old posterior. And this portion right here is the thing that you got right here. That's your new likelihood. That's how it updates. So now you just stick in those numbers. This one will be the 99% times that remaining portion, which is right here, also 99%, divided by the same plus, what's this one? Well, we didn't calculate that, but if you do the complement, that'll be 1%. And this one, F given C and E, will also be 1%. And then you guys can do that calculation on your own. But here's the important thing about when you learn from experience. You're taking, why it's learning from experience is you're taking that old calculation, that first run at Bayes, which you calculate at 99%, and then you're sticking it into the new equation, and that's how you actually ratchet your way up. That's how you learn from experience, by building upon what you just learned. And then you have this new evidence. And you should find that if this is 99%, that this overall thing should be even higher than that. It should be 99, like 0.99%, right? It increases your confidence. Okay, that's it for this problem. The better problem to work is homework 8, which I've referenced in the review. And all of this is just more practice with not just Bayes, but learning from experience. The new Bayes. This is one of the key moves. So in the final, you're going to be asked 1, Bayes, 2, diagram, and then 3, apply that to learning from experience. Yeah? So the new Bayes right here. Okay, that's it.